stationary points, we're going to cover what they are, how to find them, and how to classify them. So first of all, a stationary point is a point in function where the gradient of the tangent is equal to 0. This means it is horizontal. There are three main types of stationary points. We've got maximums, minimums, and point of inflection. And we will see an example of each of these in a moment. But the first thing is, how do we find a stationary point? So we have our function f of x. First thing we do is we differentiate it. So at the point x0, the derivative will be 0. So this is our stationary point at the point x0. So once we've found what x0 is, we can take the second derivative and we input x0, and then we have three criteria. If it is less than 0, then the stationary point is a maximum. If the second derivative of x0 is greater than 0, it is a minimum. And if the second derivative of x0 equals 0, then we can make no conclusions about what type of stationary point it is, and we have to use another method. If we now have a quick look at some of the stationary points, so we've got a graph here with three stationary points on it. So we've got this one down the bottom, this one up here, and then this one over here on the right. So this one is a minimum, this one is another local minimum, and then this one up here is a maximum. And you can see where their names come from. If we scroll over, we have our third type of stationary point. Draw the tangent in. And this one is the point of inflection. You can see that the gradient is 0, but it goes from a negative gradient just before here and then back down to a negative. You can also get points of inflection which do the opposite, having a positive gradient. There's the stationary point, and then back onto a positive gradient. So they're the three types of stationary point. Okay, so now we're going to do an example. So what we want to do is find and classify the stationary points of the function f of x is equal to x cubed minus 3x squared plus 8. So as explained before, the first thing we are going to do is we are going to find the derivative of the function. So the first derivative is equal to 3x squared minus 6x. And at a stationary point this equals 0. We can then solve this. If we take out factor of x, we've got 3x minus 6 equals 0. So for this to be true, either x equals 0 or 3x minus 6 equals 0, in which case x is equal to 2. So at these two, let's find the exact point. So input into f of x, which is 0 minus 0 plus 8, and 2 to the power of 3 is 8 minus 12 plus 8, which is 4. So we have found the stationary points at 0, 8 and 2, 4. The second part of the question says we have to classify them. So now we will use the second derivative, which will be 6x minus 6, and the second derivative at 0 is minus 6. Here it is less than 0, minus 6 is less than 0, so it is a maximum, local max, and for x equals 2, we've got 12 minus 6 is 6, which is greater than 0, so it's a local minimum. Min. So, to answer the question, the point 0.8 is a local maximum, and the point 0.24 is a local minimum. If we have a look at the graph for this, at the point 0.24, so it's 4, 2, we've got a local minimum, and at the point 0.8, which is there, we have our local maximum. Okay, so now we're going to have a look at what happens when we aren't able to classify the stationary point because the second derivative is equal to 0. So we have the equation f of x equals x to the 4. So the first thing we've got to do, as usual, is the first derivative is 4x cubed, and we set it to 0. Obviously here x equals 0. So this gives us the position of our stationary point, which will be 0, 0. Now we look at the second derivative, where the second derivative is equal to 12x squared. If we set this at our point x0, which is 0, we will get 0 again. Therefore no conclusion. So because we have no conclusion, we've now got to look at both sides of it. So if we take the point f of 1, look at 1. If we take the point of f of minus 1, we will get 1. F of 2, f of 2 is 16. F of minus 2 is also 16. So this starts to give us a picture of the graph. If we draw a set of axes and we plot the points, so we know that at 0, 0, that is our stationary point. At 1, we have got the point 1, so we'll put that there. And at minus 1, we've got the point 1. And then at 2, we've got the point 16, so we'll put that up there. So here we can sketch our graph, and you can see that this is a minimum. Ooh. And you can see that it is a minimum at the point 0, 0. And that's how we deal with the second derivative being 0.